If you've been anywhere near space content on social media over the past few months, you've probably seen a headline almost exactly like the one on this video. Webb confirms collision course, Comet on impact trajectory with Mars, countdown to impact. And I want to be straight with you right at the top, because it matters more than almost anything else we're going to talk about today. That headline is false. Not technically true, but exaggerated. Not true at the time, but outdated. False, and provably so from NASA's own published tracking data, sitting in the open right now for anyone to check. Not a collision might still happen later. Not scientists are still debating it. False, full stop, in a way that a few minutes on NASA's own website will confirm for you directly. The James Webb Space Telescope never confirmed a collision course with Mars, because there isn't one. Because the object in question already passed Mars months ago, at a very well-documented, very safe distance, and is currently speeding away from the entire solar system for good. So instead of repeating a claim that isn't true, we're going to do something better. We're going to tell you what actually happened when an interstellar comet swept past Mars in October 2025. Because the real story, backed by NASA, the European Space Agency, and even China's Space Agency, is stranger and more interesting than the fake one. It involves 3 different countries' spacecraft. Cameras that were never built to do this job, a government shutdown that delayed the pictures for weeks, and a comet that scientists now believe may be older than our entire solar system. None of that needed to be invented. It just needed to be reported properly. Let's start with what this object actually is, because that context matters for everything that follows. On July 1st, 2025, a NASA-funded survey telescope called ATLAS, operating out of Rio Hurtado, Chile, picked up a faint, fast-moving point of light that didn't match any known asteroid or comet orbit. Follow-up observations confirmed it within days. This was an object from outside our solar system entirely, only the 3rd ever confirmed, after Oumuamua in 2017 and Borisov in 2019. It was officially designated 3I Atlas, the 3I meaning third interstellar object, and Atlas, crediting the survey that found it. According to the discovery paper posted to the ARCS of preprint server, its orbit is the most extreme ever recorded for anything passing through our solar system, moving at roughly 60 kilometers per second relative to the Sun on a trajectory so steep, so hyperbolic, that there was never any question of it being captured into orbit around anything. It came from somewhere else, it's passing through once, and it's leaving for good. That last part is worth repeating, because it's the single fact that makes the entire collision course narrative impossible from the start. An object moving that fast, on a trajectory that's steep, physically cannot loop back around for a second pass at anything. It only gets one flyby of the inner solar system, and by the time anyone online was posting about an impending Mars impact, that flyby was already finished. For scale, NASA's own estimates place the comet's nucleus somewhere between about 440 meters and 5.5 kilometers across, a fairly wide uncertainty range. That's typical for an object this faint and this far away, wrapped in a coma of gas and dust that makes the solid core underneath almost impossible to measure precisely with current instruments. It's worth comparing it briefly to the 2 interstellar objects that came before it. Oumuamua, discovered in 2017, looked more like a bare, elongated rock, with no visible comet-like activity, which made its own trajectory quirks genuinely puzzling to scientists at the time. Borisov, in 2019, behaved much more like a familiar comet, with an obvious tail. 3I's Atlas sits somewhere in between in terms of how much attention its behavior has drawn, active enough to produce a real, measurable coma and tail, but unusual enough in its chemistry and its age that plenty of legitimate research groups are still actively arguing over the details in published papers. That legitimate scientific debate is also, honestly, part of why speculative claims about this comet spread so easily online, since a comet that's already the subject of real, ongoing disagreement among credentialed scientists is fertile ground for even wilder unsupported claims to graft themselves onto. A small number of researchers, most prominently the Harvard astronomer Avi Loeb, have publicly floated the idea that some of 3I Atlas's characteristics are anomalous enough to warrant considering, among many other explanations, whether the object could be artificial in origin. That is a real position held by a real scientist, and it's worth naming plainly rather than mocking or hiding it. But it's also firmly a minority view, one that the overwhelming majority of astronomers studying the object, including the teams running Hubble, Webb, and the Mars orbiters we're about to walk through, do not share. The mainstream, well-evidenced picture, backed by the actual chemical and trajectory data collected across dozens of instruments, is that 3I Atlas is a comet, an old and unusually well-studied one, but a comet. That distinction matters because a lot of the more sensational headlines floating around, including the collision course claim in this video's title, tend to borrow the aura of controversy around the object's nature and misapply it to a completely separate and completely false claim about its trajectory. So what did actually happen at Mars? In early October 2025, 3i Atlas made its closest approach to the red planet, and multiple space agencies had spacecraft already there, in orbit or on the surface, well positioned to take advantage of it. According to the European Space Agency's own account, released through their science communications team, the comet's closest distance to Mars occurred on October 3rd, 2025, at a separation of about 30 million kilometers, which works out to roughly 18.5 million miles. That is not a near miss. That is not uncomfortably close. For comparison, the average distance between Earth and the Moon is less than 400,000 kilometers, meaning 3i Atlas passed Mars at roughly 75 times farther away than the distance between our own planet and its moon. To put it another way, if you shrank the Earth-Moon distance down to the width of a single sheet of paper, the gap between 3i Atlas and Mars during this close approach would still stretch most of the length of a football field. Nothing about that number describes a collision course. It describes a very distant flyby that happened to be close enough in the vast scale of the solar system for nearby instruments to actually detect something. And multiple instruments did. ESA's ExoMars, Trace Gas Orbiter, a spacecraft that has been circling Mars since 2016 studying the planet's atmosphere for traces of methane, turned its color and stereo surface imaging system, normally used to photograph Martian terrain a few hundred kilometers below, up and away from the planet entirely, toward a dim, fast-moving smudge of light nobody was certain it could even detect. ESA's own release notes are candid about the uncertainty going in. Mission scientists genuinely weren't sure the attempt would produce anything usable, given how faint the target was at that distance, using a camera never designed for this kind of long-exposure deep space imaging. It worked anyway. Between October 1st and 7th, the orbiter, along with its sister spacecraft Mars Express, which has been operating at Mars since 2003, captured a series of images showing 3i Atlas as a small, fuzzy glow of light. Its motion so fast relative to the background stars that those stars appear as thin streaks behind it, smeared by the comet's own speed during each exposure. NASA's own hardware got involved too, though with a complication worth mentioning honestly, rather than glossing over. The United States government shutdown in the fall of 2025 delayed NASA's public release of its own images for weeks, even though the pictures themselves had already been taken. That's according to reporting from Universe Today, which noted that ESA and China's National Space Administration were both able to release their Mars-based comet images well before NASA could, simply because of the funding lapse affecting operations back on Earth, not because of anything wrong with the data itself. Once the shutdown ended and NASA resumed normal operations, the agency released imagery from 3 separate missions all at once. The Mars Reconnaissance Orbiter, using its HiRISE camera, the most powerful imaging instrument ever sent to another planet, rotated away from its usual job of photographing the Martian surface and captured 3i Atlas on October 2nd, 2025, from a distance of about 30 million kilometers in a 3.2-second exposure. According to the camera team's own published notes at the University of Arizona, which operates HiRISE, the comet's actual solid nucleus, estimated from earlier Hubble observations to be at most a few kilometers across, was far too small to resolve even at that resolution. What HiRISE could see, and did see clearly, was the coma, the surrounding cloud of gas and dust boiling off the nucleus as sunlight warmed it, a glow so extended that it filled the entire frame of the image, with only the brightest inner portion actually visible given how short the exposure had to be. The team was candid about the image's imperfections too, noting that spacecraft jitter during the observation smeared the comet across several pixels, since HiRISE simply isn't built for exposures this long. It's designed for split-second snapshots of a bright, nearby surface, not a faint, distant target crawling across the frame. That kind of honesty about an instrument's limitations, printed directly next to the image rather than cropped out of a thumbnail, is exactly the sort of detail that gets lost when a raw NASA release gets clipped down into a dramatic 30-second reel somewhere else. NASA's MAVEN spacecraft, whose entire mission is normally focused on studying how the Martian atmosphere leaks away into space, also turned its instruments on the comet, capturing it in ultraviolet light on October 9, 2025, revealing the halo of gas surrounding the nucleus in wavelengths invisible to the human eye entirely. And on the ground, NASA's Perseverance rover, the same 6-wheeled robot currently drilling into rock samples in Jezero Crater, also captured images of 3i Atlas from the Martian surface itself, meaning this comet was photographed simultaneously from orbit and from the ground of another planet, an achievement that had essentially only happened once before, when the same Mars Reconnaissance Orbiter and MAVEN spacecraft repositioned themselves to observe a different comet, known as Siding Spring, as it passed near Mars back in 2014. That earlier precedent mattered a lot to mission planners this time around, because it meant the teams running MRO and MAVEN weren't improvising blind. They'd already worked out, more than a decade earlier, roughly how to reorient an orbiter built for one job to briefly do another, and simply reused and refined that same playbook for 3i Atlas. China's Tianwen-1 orbiter, part of the China National Space Administration's own ongoing Mars program, captured its own images of 3i Atlas during this same window, according to reporting compiled by Universe Today, making this genuinely one of the only times in history that spacecraft belonging to 3 separate space agencies, American, European, and Chinese, ended up independently observing the exact same interstellar visitor from the exact same vantage point in space, entirely because it happened to wander close enough to a planet where humanity already had machines waiting. None of these agencies coordinated the observation as some kind of joint mission. Each one simply recognized, on its own, that the opportunity was too rare to pass up, which is arguably a more compelling detail than any single image any one of them produced. 3 governments, 3 completely separate space programs with 3 completely different sets of political priorities back on Earth, all independently arrived at the same conclusion. Point the cameras up. Here's what makes this whole episode worth telling accurately rather than dressing it up with a fake collision claim. None of these instruments were built for this. HiRISE exists to scout out safe landing sites for future Mars missions by photographing boulders and dust devils on the surface. MAVEN exists to study atmospheric escape. The Trace Gas Orbiter's camera exists to hunt for methane seeps in Martian rock. Perseverance's cameras exist to examine rock texture up close for signs of ancient microbial life. Every single one of them got repurposed, on short notice, by scientists who recognized that an object from another star system happening to pass within camera range of Mars was too rare an opportunity to waste, even if it meant pointing multi-billion-dollar hardware away from its actual job for a few days. That's a far more interesting story than a fabricated impact scenario, because it's a story about how flexible and how genuinely curious the people running these missions actually are. While all of this was happening at Mars, 3i Atlas was becoming steadily more interesting to observatories elsewhere too, and it's worth tracing that timeline because it explains why interest in this object exploded the way it did across so many different corners of the internet. The Hubble Space Telescope had already captured the first detailed image of the comet's shape back in July 2025, shortly after its discovery, when it was still around 277 million miles from Earth. As it swung closer to the Sun through the rest of 2025, becoming too close to our star and Earth's sky to observe from the ground for a stretch of weeks, it was these planetary missions at Mars, positioned differently in space, that kept eyes on it during the one window when Earth-based telescopes simply couldn't. That's the actual reason NASA and ESA scrambled to use Mars hardware at all. Not because the comet posed any danger, but because it was the only way to keep tracking a rare one-time visitor during the exact period it disappeared from Earth's view behind the glare of the Sun. Once 3i Atlas re-emerged into visibility in late November and December 2025, the observation campaign only intensified, drawing in telescopes and mission teams that hadn't been involved during the earlier Mars flyby window at all. Astronomers using Gemini North, an observatory on Mauna Kea in Hawaii, imaged it again on November 26th, this time as part of a live public outreach program that lets students watch professional astronomers work in real time. The Hubble Space Telescope observed it a second time on November 30th, from a distance of about 286 million kilometers, using its Wide Field Camera 3 for an even sharper look than its first image months earlier. The James Webb Space Telescope turned its MIRI infrared instrument toward the comet around the same period, and this is actually where Webb's real documented contribution comes in, not a collision warning, but a chemical one, drawn directly from spectroscopy rather than from any kind of trajectory modeling. According to NASA's published results, Webb detected methane in the comet's surrounding coma, along with earlier detections of carbon dioxide and water vapor from other instruments, evidence pointing toward a composition that formed under conditions genuinely unlike anything native to our own solar system, light years removed from the chemistry that built the planets we actually live among. Around the same window, NASA's SphereX mission separately picked up organic molecules in the gas cloud surrounding the nucleus, adding yet another independent line of chemical evidence to the picture. None of that is a threat assessment. It's a chemistry lesson, and a fairly profound one, because it means we're getting a direct sample, through spectroscopy, of material that assembled itself around a completely different star, light years away, long before it ever wandered into our neighborhood. Mars wasn't the only spacecraft caught off guard by this object either. The European Space Agency's JUICE mission, short for Jupiter Icy Moons Explorer, is on a multi-year cruise toward Jupiter, where it will eventually study the potential habitability of 3 of Jupiter's largest moons, Ganymede, Callisto, and Europa, each suspected of hiding a subsurface ocean beneath its icy crust. JUICE was never built or equipped for comet photography. It happened to be in a useful position in space during the same November 2025 window when Hubble was taking its second detailed look, and mission scientists pointed its cameras at 3i Atlas anyway, returning images that, according to reporting from CNN, showed intriguing activity around the comet's nucleus, even though the instrument doing the observing had an entirely different job description. That's now 3 separate categories of spacecraft: a Mars-orbiting atmosphere probe, a Mars surface geology rover, and a Jupiter-bound moon explorer, all repurposed at different points to look at the same object, alongside ground-based observatories doing the same thing from Earth. Speaking of ground-based observatories, Gemini North, perched atop Mauna Kea in Hawaii, captured its own images on November 26, 2025, using an instrument called the Gemini Multi-Object Spectrograph, revealing a faint greenish glow around the comet's coma, a color astronomers associate with specific carbon-based molecules being broken apart by sunlight as the comet continued its journey away from the sun's heat. That observation happened as part of a public outreach program called Shadow the Scientists, which lets students around the world watch professional astronomers conduct the observation live, another detail that cuts against any narrative of secrecy or cover-up around this object. If NASA, ESA, and independent observatories were hiding something about 3I Atlas, it's an odd choice to invite classrooms full of students to watch the telescope work in real time. There's also been genuine published scientific debate over something called non-gravitational acceleration, meaning small deviations in a comet's path caused by gas jetting off its surface unevenly as it's heated, rather than by gravity alone. According to reporting from Sky and Telescope, some researchers floated the possibility that 3I Atlas showed signs of this effect, which is common enough in ordinary comets, but became a point of intense scrutiny with Oumuamua back in 2017, since that earlier interstellar object showed unexplained acceleration despite displaying none of the usual signs of gas or dust being released, a mismatch that fueled years of speculation about what Oumuamua actually was. But sources quoted in that same reporting, including researchers at the Center for Astrophysics at Harvard and Smithsonian, have pushed back on the idea that 3I Atlas is behaving anomalously in this respect at all, noting there isn't strong evidence the effect is present in this case, the way it clearly was with Oumuamua. This is what real, functioning science actually looks like while it's happening. Competing groups publishing competing interpretations of the same data set, disagreeing openly, and settling things through more observation rather than through a single dramatic headline. It's slower and less exciting than Collision Course, but it's also the only version of the story that's actually true. Several research groups studying 3I Atlas's motion and composition have suggested the object could be extraordinarily old, potentially predating our own solar system by billions of years, meaning that by the time this comet ever formed, the Sun, Earth, and everything else in our neighborhood didn't exist yet. It may be one of the oldest solid objects any human instrument has ever directly examined, older, by some estimates, than the star system it originally came from. That's a genuinely mind-bending fact, and it's one grounded in actual published spectroscopic analysis, not speculation dressed up as a headline. So where's 3I Atlas now, and where is it going? It made its closest approach to Earth on December 19, 2025, passing at a distance of roughly 167 million miles, or about 270 million kilometers. According to reporting from the Associated Press at the time, a distance NASA and independent astronomers were consistent in describing as posing absolutely no risk to our planet. For a second point of comparison, that's roughly the same as the average distance between the Sun and Mars itself, meaning that even at its single closest pass by our own planet, 3I Atlas was never anywhere near Earth in any meaningful sense either, let alone Mars, which it had already passed 2.5 months earlier. It is now moving away from the Sun, back out toward interstellar space, on the same one-way trajectory it arrived on, never to return. There is, interestingly, a genuine and difficult proposal being discussed among some mission planners to attempt an intercept mission, sending a spacecraft to catch up with it before it's gone for good, precisely because these interstellar visitors are so rare and so scientifically valuable that even a distant high-speed pass is worth the attempt, even though the odds and the engineering challenge of actually pulling that off, given how fast the comet is already moving away, are steep. That's a real ongoing conversation in the space community, weighed publicly in mission planning circles with real trade-offs and real skepticism about feasibility. A Mars impact is not a real ongoing conversation anywhere in that same community because it was never a real possibility to begin with. It's worth asking, honestly, why a claim like Webb confirmed a collision course with Mars spreads as easily as it does when the correction takes about 30 seconds of checking NASA's own public tracking pages. Part of it is timing. 3I Atlas genuinely was a huge story for months. Genuinely was observed near Mars, genuinely did involve dramatic-sounding words like interstellar and hyperbolic trajectory that sound ominous out of context, even though they simply describe how fast it's moving and where it came from. Take a true, exciting, complicated story, swap out one detail, flew past, for collision course, and you get a headline that spreads far better than the real one, right up until someone actually checks. The frustrating part is that the true version didn't need the swap. 3 space agencies, 5 spacecraft, a comet possibly older than the sun itself, and a government shutdown that delayed the photos. That's already a better video than a fake apocalypse. There's another layer to this worth naming plainly, because it explains why this particular myth in particular took hold so easily. Collision course with Mars is a testable claim with a very short shelf life. Either an object hits a planet on a predictable date, or it doesn't. And once that date passes without incident, the claim should, in theory, collapse under its own weight. But by the time a video title like this one circulates widely, gets clipped, reposted, and re-uploaded across a dozen different channels with slightly different thumbnails, the original claim has often already outlived its own falsifiability window in the public's memory, becoming just another vaguely remembered thing NASA found, rather than a specific checkable prediction that failed to happen. That's part of why it's worth stating plainly and clearly on the record, in a video like this one, no collision happened, none was ever predicted by any actual NASA, ESA, or JWST publication, and the object in question is now well past Mars and accelerating away from the entire solar system, never to return. It's also worth sitting for a moment with how differently NASA and ESA actually communicate uncertainty compared to how this kind of content typically frames it. When ESA's own team wasn't sure the Trace Gas Orbiter's camera would even be able to detect something as faint as 3I Atlas from 30 million kilometers away, they said so, plainly, in their own public release, before showing the result, rather than waiting to see what worked and only then pretending they'd been confident all along. When the HiRISE team at the University of Arizona published their October 2nd image, they explained exactly why the comet's actual solid nucleus couldn't be resolved in the frame, rather than presenting a blurry smudge as more dramatic or more mysterious than it actually was. That habit, stating the limits of what an instrument can and can't do before showing what it found, is a big part of why these agencies' own publications are worth trusting more than a repost with a manufactured headline slapped on top. Nobody at NASA or ESA needed to invent a collision to make this story compelling. The actual constraints of the instruments and the honest descriptions of what they could and couldn't see were interesting enough on their own. If there's a single takeaway worth sitting with here, it's this. The actual archive of what happened with 3I Atlas at Mars in October 2025 is public, dated, and credited down to the individual camera and the individual day, sitting on NASA's Jet Propulsion Laboratory site, on the European Space Agency's own science pages, and in the University of Arizona's HiRISE mission logs, exactly the sources we pulled from putting this video together. You can go check every claim we just made yourself in a few minutes the same way we did. That's always going to be a better foundation for a space video than a headline nobody sourced, because 6 months from now, when the next confirmed collision course video shows up in your feed about some other object, you'll already know exactly where to go check whether it's true. And that, honestly, is the more useful skill to walk away with from a video like this one, more useful even than any single fact about 3I Atlas itself. It isn't really about memorizing which comet passed which planet on which date, and by the time you're watching this, some of those specific numbers may already be superseded by newer observations as the comet continues its way out of the solar system. It's about knowing that these agencies keep receipts, that every image has a date and an instrument and a distance attached to it, and that a claim about a confirmed collision course ought to come with a link to an actual NASA or ESA statement, not just a dramatic thumbnail and a synthesized voice reading a script nobody bothered to check. If a future video on this channel or anywhere else ever makes a claim that dramatic about a real object again, the same test applies. Does it link back to an actual mission page, an actual press release, an actual named scientist standing behind the number? Or does it just sound urgent enough that you weren't supposed to stop and ask? Tell us in the comments which part of the real story surprised you more. The fact that 3 countries, space agencies all photographed the same comet by accident, or the fact that some of the instruments involved had to be pointed away from their actual jobs to do it. Either way, that's the story that actually happened. It's fully documented across 3 continents worth of public space agency archives. And it was good enough on its own without a single invented detail.